I do some consulting work on American
feeling in the room was
You
palpable.
don't ever say to her that her
One about the Chautauqua Institute.
Introductory discussion on the ethical implications more of a community.
before China took back over.
Currently doing in autism.
Dr. T. Colin Campbell has spent more than 40 years researching the link between diet and diseases. His best-known work, the China Study, explores the health benefits of plant-based nutrition and has sold more than 1 million copies. A professor emeritus at Cornell University, Campbell has given more than 600 public lectures, written over 300 research papers, and been featured in several documentary films. We'll talk with him about what led him to his China Study, about his most famous convert, Bill Clinton, and about why so many Americans consider a plant-based diet so radical. Here's our conversation with T. Colin Campbell. Colin Campbell, thank you so much for joining us.
Thank you. It's a pleasure.
You attended Penn State in their pre-veterinary medicine program, later went to Cornell University where you studied biochemistry and nutrition with the idea that you would learn something to take back to your Virginia dairy farm. In fact, you thought that you would figure out how to produce more efficiently animal protein. What happened? What changed your thinking?
That's exactly what happened. It was traditional to think that way, whether we're on the farm or whether I was in school at the time. And so I did that, then left school, went to MIT to work for 3 years there as a research associate. It wasn't until I went to Virginia Tech in the Department of Biochemistry, and then working in the project that we had in the Philippines.
You were working with malnourished children, with the belief that what they need is more protein.
That's exactly right, and that was commonplace. I mean, everybody sort of knew that. That was, who didn't think that kind of thing. There was said to be a protein gap in the world. That was big news, even out in the public. So
a protein cap?
Gap.
Gap,
yeah,
okay.
Not enough.
Right.
And so, and there were a number of universities developing projects to make sure that the poor countries got enough of this protein. Various kinds of projects. So when I went there, we were doing the same thing in a way, and then I saw this really unusual, or heard about this very unusual case or cases where some very young children were getting liver cancer. And that was my other hat. I was interested in cancer and how it works and so forth. And I was hearing that those few families consuming the most protein, like we do in the West, their children are more likely to get the liver cancer. And that was pretty odd. I mean, here we're going there to make sure everybody has come up to that level, but then hearing this, I mean, actually I have to admit, that was kind of superficial reasoning at the time. We didn't have all the facts on liver cancer, but the fact is that that's what came into my head. And then there was this report from India, experimental research report with experimental animals, showing the same thing. You know, animals programmed to get liver cancer fed higher levels of protein as opposed to lower. The ones with the higher levels of protein are the ones that got the cancer. It's quite dramatic, major difference.
The conventional wisdom is that protein is a superfood, that we need between 10 and 35% of our calories should be consumed in protein. You believe it should be 10% or less.
Well, just about 10%. I don't even think too much about the numbers anymore, because it turns out if you eat vegetables, fruits, grains, legumes, one's going to get somewhere in the neighborhood of at least 10, 8 to 10. And actually, if you're eating a lot of legumes, you can get it up to 15, 16, 17%, which incidentally is not a problem. It's when it's in the form of plant-based foods, because what is taken along with it, even though the protein in theory might be causing some problems, which it probably doesn't, but in any case, it brings along with it all the antioxidants and complex carbohydrates. That's just nature. So when we're getting it from plants, we can get easily 8 to 10%, and it could be higher. So my point is that even 8 to 10% is plenty. That's very similar to what we have been recommending for years as the recommended dietary allowance.
Well, we'll talk a little bit about how the American diet has evolved in the last 5 or 6 decades.
Well, you know, it's even maybe a little longer than that for that evolution, going back to, let's say, a century, late 1800s. Protein was discovered in 1839 in Europe. And it was characterized as the stuff of civilization itself, as one of the people doing that said. And so the early researchers, mostly in Europe at that time, were just revering this special nitrogen-containing nutrient, and that it was needed to for dogs.
Life itself.
Yeah, for dogs to survive, was dogs in that case. And so they got really enthused about this, and I think their enthusiasm occurred because they got the protein from the meat. They knew it was the meat. And so the thought arose that this protein was what makes meat good. And so meat and protein became almost synonymous. It wasn't until maybe 30, 40 years later or so that they started to realize that protein was in plants. But that didn't set too well, because the people who equated protein with meat, they kind of liked the idea. They wanted to eat meat. And to say it's in plants, all of a sudden this new concept arose. The plant protein was called poor quality compared to the animal protein, high quality. So that sold well, essentially, in the ensuing decades. If you wanted to get real protein, good quality protein, you had to get it from animal-based foods. That was it.
And in fact, the mindset is that meat is macho and that a vegetable-based diet is wimpy and weak and really very unappealing.
Exactly. There was a comment made by the senior medical advisor for the United Kingdom Empire in India at that time, medical doctor, that they were at that time wanting to find the different tribes of India to provide soldiers for the army at the time. And I read some of this old stuff, and the medical advisor was talking about these different tribes, finding the ones that ate the most meat as being the super people. And he described that those who don't do that are of an effeminate nature. So, that machoism was alive and well, and that was, I think, 1912.
Tell us a little bit about your China study. You started your research in 1974, came out with your book not until 2005, and most people who've heard of your China study associate it with many with Bill Clinton, who's one of the probably best known followers of the China study diet,
right,
which is a low-fat, low-meat diet. Tell us more about it.
Our own research program started in 1965, and then from 1965 in the Philippines on up until about 1980, it was strictly that idea of exploring the effect of protein on cancer in the laboratory. In 1980, that's when the United States and China first started talking to each other, and the first senior scientist from China to come to the United States came to work with me. And so his name was Dr. Chen, and Dr. Chen and I sort of spent a year together, and we learned about the China government having just produced an atlas of maps showing where
the cancer atlas. So geographically,
exactly,
where is this cancer?
Sure enough, and that occurred to me that at that time I'm kind of into the diet and cancer thing a lot, and he came to work with me in part for that reason. And so I just made a suggestion, it would be kind of interesting to go there and see why is cancer so common here and not there, kind of thing. And one thing led to another. He knew the senior investigator of the Cancer Atlas study, which involved, incidentally, about 600,000 workers. They were collecting data on a total of about 800 million people, how much cancer was occurring in these different counties. So we got together and talked about doing a study. Well, I went to NIH. He went to his government. One of his government people came to speak with me. We got to know each other, talking more. I was sent by our NIH to China on a fellowship to go see what might be possible. And so a lot of people were getting involved in playing in this new opportunity. And we got the money. And this was the first project between the United States and China in the area of research. That's how it started in 1983. And then we spent from 83 and somewhat in 84 collecting information in the field. We had a total of about 250 workers.
6,000 people were studied?
6,500 families. That's right.
In 60 different counties?
And
in rural China?
Yes. Or, it was, as we also say, 130 villages, 2 villages per county. So we collected all this information, the most comprehensive collection of data ever. for a medical project. Collected it from 1983 or 84 or so until about 1988. We were just assembling the data, cleaning it up, so to speak. We eventually had, and analyzing the samples, and we had about 24 laboratories around the world working. And when I say we, I need to tell you that my chief partner in many ways is Sir Richard Peto. Richard Peto at the University of Oxford. So I went to Oxford, had a position there too. And Richard and I and others at Oxford and the ones in China, we all got together assembling all this information. Finally, we sort of had it cleaned up, in a sense, in a tabulated form along about 1989, 1990. And then it was jointly published as a big book, about 900 pages, with all the data. It was jointly published by Cornell University Press, the Oxford University Press, and the China People's Publishing House, as they said. So it was a joint publication between our three countries. That was in 1990. Then it caught the attention of a lot of media people in this country, including the New York Times, the USA Today, Saturday Evening Post. They all ran cover stories on this. Then it got a lot of attention. But
not all of it good. You said that there's
no.
been, in fact, enormous hostility and antagonism for promoting the ideas that came from that. You said in some respects you've been hounded for your views.
Well, that's true. I mean, I don't say it as necessarily as a personal kind of thing. I'm just sort of just describing, the scenery, if you will. And it turned out that the New York Times actually said something that was pretty provocative for us as science. They called it the Grand Prix of all studies. Really kind of praising it and all this kind of thing. A little bit going overboard. And I was not sure I liked that description. And so I called up the reporter from the Times and even asked her, I said, why did you put that title in there? Why? I said, that's stretching it a little bit. And she said, I didn't do it. She said, the editors did it. And the same thing happened with the USA Today and New York Times. They were anxious to describe this in glowing terms. A little bit more.
Why do you suppose they were so anxious about what you were saying? And
Well,
what you were saying was we need less protein, and that protein is implicated in cancer.
Well, there are two reasons. One is, at that time, keep in mind, the United States and China are just really starting to work out some relationships and things like that. Our relationship was probably one of the most successful. It was written up. In fact, I was invited on one occasion about that time to come to a joint meeting of senior Chinese, United Nations, and American leaders to describe why was I so successful in China compared to other people who were trying to get projects started. So it was getting that reputation. And they wanted everybody's interested in China. And that was partly it. But then, so they wrote the thing up as pretty grandiose. They say I kind of reacted negatively. And because I thought that's putting me in a little bit of difficulty in my supposedly very objective field of science. I came home to my wife and I said to her, what am I going to do? Am I going to retract that? Am I going to say, hey, that's going too far? And when I looked at it, they did a good job writing it up. It was all true. So I said...
Well, tell us what the basics of your findings.
Well, the basics is that in rural China, where our study was, basically, we were, and that's where we pretty much stayed as far as the survey was concerned, and their diets were really low in fat. The average fat content was only 14.5%, whereas ours is like 35. I mean, low in fat, high in dietary fiber, high in plant material. I mean, there was a range there for different counties, but very low. So it was a kind of situation where I wasn't sure that we'd see anything. I thought perhaps all these people are eating plant-based diets and, that's probably good enough. But we saw within that range the same trends like higher cholesterol consumption or higher cholesterol in the blood or higher animal protein consumption and so forth. We were starting to see these trends that going from a very low level, almost no animal foods, to only a modest level, the diseases started to appear. That was pretty provocative too. That was consistent with what I had been seeing in the laboratory. In the laboratory,
you were focusing on a particular protein, casein, which is very high in cow's milk. Tell us a little bit about what you found there and what you concluded.
Well, the casein studies were done in our experimental animals in the 70s, well, late 60s, 70s, and on the 80s. And I was just using that as a means to disturb the cancer process, so to speak, so I could understand the cancer process. But it was almost like the tail wagging the dog, because we're using a protein to do what I'm really interested in, but all of a sudden realized this casein, this protein thing, if you will. And so then I realized that we're using casein. Well, that's pretty provocative. And what about some other proteins? So we looked at a couple more plant-based proteins, and they didn't do it. I mean, all of a sudden, the light bulb's coming on in many different directions. And I'm saying, you know, this whole question concerning food as it relates to cancer and possibly heart disease is pretty much focused on animal food as being the difficult part of it. And so that, I mean, my whole research program and ideas were expanded.
Explain to me, if you would, you know, we are, will quickly accept that diet results in disease, for instance, obesity and heart disease, but Americans have a difficult time doing the opposite, saying, well, if a poor diet leads to disease, could a good diet reverse disease? And Americans have a very difficult time swallowing that.
Yes, of course. I mean, you know, as was described by some of the early researchers in the early 1900s, for example, when they were talking about higher protein consumption, animal-based food, they called it the stuff of civilization itself. And so you can see in the old history, the literature, this emerging idea that animals are there for us to eat, and milk is there for us to drink, because it has these wonderful properties. But those ideas were culturally embedded and philosophically oriented, I think, and for various and sundry reasons, and it really caught hold. And then the industry started forming around that too. You know, the livestock industry, the dairy industry, and so forth and so on. So it just continued to grow in and of itself.
Have you gotten much pushback from those industries?
Oh, yes.
Because of your message?
Of course. The dairy industry, of which I was a part, my first publication actually was in the Journal of Animal Science. And my first offer of a position actually was here at Penn State. For a faculty position, I was offered a position when I was quite young as a professor of dairy science. I turned it down, but I was very much in that camp. So in any case, as our research unfolded, I'm seeing something different. You know, there's something else here that's a little more exciting. And now I've become quite fascinated with the whole history of this field, all the way back to Socrates and Plato and Pythagoras. You know, they said at that time, Plato has it in his dialogues, that, you know, people who basically eat that way get a disease that he described as looking like cancer. You know, it's really interesting. The ancient Greeks, insofar as their science was concerned, they were quite clever. They were making observations that turned out these days to be quite true. And they also said, too, there's stuff in that old literature to say that the Olympians of their day, that's the athletes, knew to eat this kind of food that was better for them. And we've wrestled with that ever since the last 2,000 years.
Today, elite athletes may eat as much as 40% of their calories in protein. The Physicians Committee for Responsible Medicine would like to change that, and so they have enlisted high-performing athletes who are now eating a whole foods, plant-based diet.
Right.
Do athletes need more protein than the average person?
I don't think they do. I mean, I guess we can still debate that question a little bit. When I was working with Tony Gonzalez, for example, the football player, and a couple of other individuals on this question, they were asking me, well, how much protein should I really have? You know, kind of thing. And I couldn't answer with any very definitively at that point. At least extra protein to do what they wanted to do, that is, achieve their athletic...
Build muscle.
Yeah, build muscle, run faster, whatever. And as we started thinking about it, the more looking at it and watching some of the athletes, what happened to them when they changed, I said, wait, this is ridiculous. They don't need that protein. And in fact, then I was learning too that from two sources, familiar with the facts, I think, and that the people who ate the most extra protein, the athletes who ate the most extra protein, they die at a remarkably young age. They gain a lot of weight, they get a lot of muscle and all that kind of thing, but then they get diabetes and they get cancer and they get obesity and heart disease and so forth.
You talk about the importance of a spare yet nutritious diet. So how many calories, when we look at cancer, it's not just fat and sugar and all of those things, but also how many calories we're consuming.
Well, to some extent that's true. Actually, you might be surprised to learn that yes, if we eat too many calories, that's too much food. I should say, usually that's the wrong kind of food. We're doing two things: increase in quantity, not expending it, and eat the wrong kind of food. That could lead to problems very clearly. So it leads to this idea: calories in is a bad problem, and it is to some extent. But in reality, in our experiments, we found that after 25 years, doing this many, many times, in the animals that got the least cancer consumed the most calories. Not very much more, but it's significant. They consumed the most calories. And so we actually researched that question quite a bit to find out what happens to these calories. How can they get away with eating all these extra calories? And it has to do with the fact that those calories being consumed on a plant-based diet, a larger proportion is expended as body heat and or voluntary or involuntary physical activity. So it tends to make us feel better. We get more energetic. It starts to make sense. And so what we saw in the animals that I also saw in the Chinese population.
You like to use the term whole foods, plant-based diet,
Right.
as opposed to vegetarian or vegan, which of course is a stricter form of vegetarianism. Why that term, and what exactly does it mean?
Well, first off, I very much appreciate the fact that the vegetarians and vegans, as communities, kind of support our work and are advancing the cause, and they're in a sense doing the right thing in many ways. They arrived at their opinions mostly for ideological reasonings, as we all know, and that's not sufficient to convince a lot of people, of that practice. But the problem is that vegetarians, 90% of those people still use dairy. So the nutrient composition of their diets is not that different than non-vegetarians. And it's the nutrient composition that really matters. Amount of fat, amount of protein, so forth. The vegetarians are substituting milk for meat in large measure, maybe eggs too. Vegans, they're avoiding all animal foods, we all know that. But what they don't consciously think too much about the science. And so they end up eating processed foods and all
We've
this
all
kind
heard
of
of
stuff.
the vegan junk food junkie.
Junk, exactly. Too often, just a recent study of the largest study on vegans showed that the average fat content in the diet is 30%. Their diets are not very good. And we see some health advantages, of course, for vegans and vegetarians, but it's not what it could be if they really follow the science.
So explain for us, what do you mean then by whole foods? What ones are you recommending, and especially which ones are high in protein?
Well, we say vegetables, fruits, grains, legumes, maybe some nuts, of course, too, in a whole food form. And then and what I'm saying about that is that we can grind them up if we want to, or whatever we do with them. We can cook them to some extent. That's not a big deal. It's just the fact of keeping the whole thing intact. Instead of, for example, in the case of grains, we refine them. We take the hull away. We're taking the best part away and throwing it, feeding it to pigs. We've been doing it for years. And so, and we just tend to do that. We throw the peels of vegetables and so forth away, sometimes, like maybe peel apples, whatever. And it's really the whole intact food, best served fresh, obviously, as much as possible. It doesn't have to be raw, but we do that naturally. We eat fruits pretty much raw. And so when I'm talking about the whole food, I know the term is not, it doesn't just flow off the tongue very easily. And I'm the one that devised that term because I was very conscious of the fact that my scientific colleagues were perturbed by those words, vegan and vegetarian, and they weren't doing the right thing anyhow, so I was looking for something more relevant in science.
How optimistic are you that this will take hold?
Well, I have given at least more than 600 lectures since our book came out, and that book itself has sold 1.5 million copies. That's a China study. for starters. And a lot of celebrities and other people have sort of picked up on it. But in my lectures, in the last 4 or 5 years, I'd say, the majority of my lectures now have been to medical schools. That is very exciting. I just came from Los Angeles 2 weeks ago, speaking to an audience of 600. 95% of them were primary care doctors. Then I went to Spain right after that. That was a medical association. There were national medical meetings. And then in Slovakia, Italy, there were a lot of doctors. It's just
Thrilled that there's interest in the medical.
It's from the medical community. That is
for
very
nutrition.
exciting. So when that happens, and this is coming from doctors who really care and they just search out the information, about this. They really care about this information. If they were all just taught this, that's the key. And so I'm trying to make a proposal to them now that we have a program, actually an online program, that we can actually do that. Just give me your medical students 3 weeks. I will change their attitude for the rest of their careers.
Food is medicine.
That's right.
Dr. Colin Campbell, thank you so much for talking with us.
Well, thank you. It's been a pleasure.
I hope you enjoyed our conversation with T. Colin Campbell. For more information on his research, visit our website at conversations.psu.edu. I'm Patty Satalia. We hope you'll join us for our next Conversation from Penn State.
Production funding provided in part by the Corporation for Public Broadcasting and by viewers like you. Thank you.